So once again, good morning to all. So let us begin our second session on the advanced training program for the fluid mechanics. Okay. So in previous lecture, we have covered up to this point kinematic viscosity, and I think we have solved this question, the SI unit of kinematic viscosity. Have you gone through this question or not? I think we have seen this question, but on the kinematic viscosity, here we have seen what is kinematic viscosity. Kinematic viscosity is nothing but it is the ratio of dynamic viscosity. Kinematic viscosity, which is represented by letter nu. So nu is equal to mu divided by rho. That is dynamic viscosity to the mass density of that particular fluid. So that is nothing but kinematic viscosity. The unit of kinematic viscosity, I think we have seen this part. 1 stoke, right? In CGS, the unit of the kinematic viscosity is 1 stoke. That is nothing but centimeter square per second, and 1 stoke is equal to 10 to the power minus 4 meter square per second, right? I think you have written this thing also in your notebook. So let us solve this question. SI unit of kinematic viscosity. Just now we have seen this question was asked in GATE 2001. So what will be the answer for this? Option number?
Meter square per second.
Meter square.
Option A. Option A.
Next question about this kinematic viscosity is, what are the dimensions of kinematic viscosity of the fluid? So this question was asked in IES 2007. Now here you might have studied dimensionless analysis, dimensional analysis, right? There we can convert any unit in the dimensions MLT, right? M is for the mass, L is for the length, and T is for the time. Okay. Any unit, it can be put in that particular dimension format. For example, here now, what is the unit of kinematic viscosity? Just we have seen it is meter square per second, right? So in dimensional analysis, length is measured in meter. So here M is we can write M as it is here, M square, right? And time, second, here unit is second, and that is unit of time, and time is represented by letter T. So it is meter square per T. Like this we can write here. So here we can write meter square and T to the power minus 1. So this is the dimension of network. Internet connection is fluctuating here. Yes. So what will be the answer for this question? Out of the 4 options, what will be the correct option for this? Am I audible? Hello? Vaibhavi?
B option.
B.
Okay. Am I audible? No?
Yes, sir.
Yes, sir.
Yes, sir.
So here network is fluctuating, so I am not getting whether I am reaching to you, my voice is reaching to you or not. Okay. Yeah, these questions we remain to solve this question. Yes. Anyone having any doubt? Okay, this question I had put it on the before the kinematic viscosity, but unless and until we know the concept of kinematic viscosity, we cannot solve this problem. So because of that, we remain there. We skipped this problem at that time. So let us solve this problem here. Okay, take your notebook, pen, calculator with you, and try to solve this problem. So this question was asked in 2005 in IES. What is the question? An oil of specific gravity 0.9 has viscosity of 0.28 stroke. Okay. Okay, let us now solve other different variety of problem. So in previous kind of problem here, the equation will be given to you, and from that equation, we have to derive the equation for that shear stress, and we require to find out what is the value of shear stress at particular value of y, that is perpendicular distance. So here there is another variety, say a different variety here of the problem. Okay, so let us solve this one basic example, then we will go for the problems that has been asked in examination. Okay, so let us write down this problem. Two horizontal plates are placed, write down, two horizontal plates are placed 1.25 centimeter apart, placed 1.25 centimeter apart. Comma, the space between them, the space between them being filled with, the space between them being filled with oil of viscosity, being filled with oil of viscosity 14 coils, 14 coils. Calculate shear stress in oil, calculate shear stress in the oil if upper plate is, if the upper plate is moved with velocity of, upper plate is moved with a velocity of 2.5 meter per second, 2.5 meter per second. This is the problem. Read the problem, write down the given things. What is given? Two horizontal plates are placed 1.25 centimeter apart. Okay, so here in the diagram you can see we have drawn the diagram. Okay, there is one plate here which is stationary. Okay, and there is another plate, second plate, which is in motion, which is moving with velocity 2.5 meter per second. Okay, this is the velocity of this plate. Okay, and these two plates are separated by a distance of 1.25 centimeter. The distance between these two plates is 1.25 centimeter. Here it is asked to find out what is the shear stress, that is value of tau, right? So we need to find out what is the value of tau. To find out the value of tau, we have the equation tau is equal to mu into du or dv by dy. Okay, this is the equation. First of all, write down the given things. They have given the distance between these two plates. So here, let us call it as a y2 and this is a y1. So dy is the difference between these two, or the distance between these two plates. So y2 minus y1, it will be equal to 1.25. So this is the value of dy in centimeter. Okay. Now convert this centimeter in meter. 1.25 into 10 to the power minus 2 meter, right? Similarly, dV is nothing but it is the difference in the two velocities, difference in the velocity between first plate and second plate. So first plate is moving with velocity of 2.5 meter. Second plate is stationary, that is 0. And here you will get dV value is equal to 2.5 meter per second. These two values you have what? The value of mu is also given. Mu is equal to how much it is? It is 14 points. Right here, 14 into 1 by 10 equal to 1.4 Pascal second. Okay, Newton second meter square or Pascal second. 1.4. Now put all these values in this problem, in this equation. 1.4 into what is dV? It is 2.5 divided by dy. It is 1.25 into 10 to the power minus 2. Solve this and tell me the answer. Okay, 280, 280, 280. Write down the unit also. Many students have got the answer 280. The unit will be Newton per meter square. Correct. Okay, here many students have got the same answer, that is 180 Newton per meter square. So let us check the answer. Correct. The answer is correct, 280 Newton per meter square. Is there any doubt in this problem? Let me know if anyone have not understood the concept, how to solve this problem. Do not hesitate, do not share to ask the question. Let it be anything, any kind of question related to this. Okay, I think no one has any doubt. So let us solve this problem. Okay. Now this problem you have to solve. I have taught you the concept, the process, how to solve this problem, such kind of problems. Okay. So let us check how many of you will get the correct answer for this. Write down the problem. So this question, it was asked in IAS, Indian, what I can say, what is the long form of IAS? IAS, Administrative Services. I think it should be IES. It should be IES. By mistake, I think they have written IES. Indian Administrative Services and Indian Engineering Services. These are the two different examinations. In IAS examination, if the technical kind of subject is there, in that it might have been asked. Okay, but generally here we Prajakta Linker will mute. So let us write down the problem. When a flat plate, when a flat plate of 0.1 meter square, when a flat plate of 0.1 meter square area is pulled at a constant velocity of 30 centimeter per second, parallel to the another stationary plate, Now see here, other plate is stationary and one plate is moving, okay, with a velocity of 30 centimeter per second. So here in your mind, you have to do the calculation that this is the value of dv or du, okay. So change in the velocity, because one plate is stationary, so its velocity will be 0. So the value of du or dv will be 30 centimeter per second. So in meter, that value will be 0.3 meter per second, right? So in the mind only you can do the calculation, such kind of calculation, and directly you can, in examination, directly you can put that values on the rough paper. Okay, there will be limited rough papers for you for the solving this such kinds of problems. So in mind also you can do some small kinds of calculations, and directly you can put the answers for that particular number. Okay. 30 centimeter per second parallel to the another stationary plate located at a distance of 0.1 centimeter from it. So again here, other value, which is that value? It is given. Distance means it is by. Okay, one plate is stationary. So you can say that stationary plate is at the distance of 0 centimeter or 0 meter, and the plate which is moving, it is at a distance of 0.01 centimeter. So directly you can put there dy is equal to 0.01 centimeter, or in meter you can put that value conversion, or directly write there 0.01 into 10 to the power minus 2 meter. Okay, from it, and the space in between is filled with a fluid of dynamic viscosity is equal to 0.001 Newton second per meter square. So the dynamic viscosity means mu value is also given. Okay, and what we have to find out? The force required to be applied is. Here we need to find out what is the force required. Okay, see here in the option also you will get there the unit for the force only. Stress is not asked here. Okay, shear stress is not asked. It is asked to find out what is the force required. Okay, so now how to find out this force? So we have discussed that shear stress, it is a kind of stress. So generally stress is given by the formula force per unit area, right? So force required to drag the plate or the pull the plate, दोन प्लेट आहेत त्यातली वरची प्लेट जी आहे त्या वरच्या प्लेटला पुल करण्यासाठी how much force is required. Okay, so here per unit area means what is this area? This area is nothing but it is the area of this plate. जो प्लेट आहे त्या प्लेटचा हा जो एरिया आहे, they are talking about this area. So that area is also given in the problem. Flat plate of 0.1 meter square area. Okay, so put that area here. By using this equation tau is equal to mu into du by dy, we will get the value of tau, and once you get the value of tau, multiply it with this area and you will get final value of f. Okay, solve this and put your answers in the chat box. Okay, some of the students have put the answers. Samaran has written 3 Newton. Then Anjali option A, Tejasri option A, Project option A. Many students have given the answer as option A, that is 0.3 Newton. See, students are very fast. Some of the students are solving very fastly. Before my explanation, they are putting the answers, means they have understood the concept clearly. So this should be your proactiveness. Suraj has got option A, Neha option A, Utuja option A. Other students also solve this. One, two, three, four, five, six, 7, 8, 9, 10, 11, 12, 13, 14. 14 students till now have given their answers in the chat box, and all of them except one, I think, have got the correct answer. I don't know the answer, but most of you have got the same answer. I think then it will be same answer. Okay, so let's check it. The correct option A is the correct answer. That is 0.3 Newton. And this is the explanation. The same I have explained you. Okay. So let us solve the next problem. This is the problem. Solve this and put your answers in the chat box. This was asked in IES examination 2001. The shear stress developed. The shear stress developed in lubricating oil. In lubricating oil of viscosity 9.81 poise filled between two parallel plates 1 centimeter apart and moving with relative velocity of 2 meter per second is after getting answers, put your answers in the chat box. Sanket has very fastly solved the problem and he has got option B. Tejasri also has got option B. Anjali option B. Shubham option B. Great. So with this speed, we have to solve these problems. Then only you will able to solve complete paper. Good. So many students have got the same answer, means that answer is correct one. Let me check it. Option B is the correct answer, 196.2 Newton per meter square. Correct. And many students, all the students have got the same answer, not exception. Those students who have put the answers, all of them are correct one. Nice. So now let us move ahead. Is there any doubt to anyone how this problem is to be solved? If no one has any doubt, then we will move ahead. Option B, that is 196.2 Newton per meter square is the correct answer. Now our next point of the discussion is variation of viscosity with temperature. So already we have studied this point also in our regular lecture classes in Introduction to Fluid Mechanics subject, right? How it varies. Does anyone remember that what is the relation of viscosity with temperature? At that time, I had made one kind of small table here like this. And here I have written liquid, and here gases. Here fluid, temperature, and viscosity. Something like this, I think we have written there. Yes. Does anyone remember the
When
relation?
temperature increases,
Okay, in case of liquid,
viscosity decreases.
one second. In case of liquids, if the temperature increases, what about the viscosity?
Decreases.
Decreases.
Viscosity decreases, correct. If the temperature decreases, then viscosity, what will happen? Increase or decrease?
Increase.
Increases.
What about the gases? If the temperature increases,
Increases.
Gases
viscosity
also increases.
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 If the temperature decreases, viscosity
Decreases.
decreases. Okay. So this table at that time we have written, and most of you remember this one. So that is great thing. So likewise, you should remember the basic concepts for lifetime. Okay. Now let us see the explanation for this. What is the explanation? Why it is like this? Okay. So here in this paragraph, that explanation has been given. Why this relation of, or the variation of viscosity with temperature is different for the liquids and for the gases. Okay. What has happened? It is not working. One minute. Yes. Now it is working. Okay. See here, viscosity, that phenomenon or that particular concept, it is governed by different entities in case of liquids and in case of gases. Okay. See here, temperature affects viscosity. The viscosity of the liquid decreases. So this is due to the reason that viscous force in a fluid are due to the cohesive forces and intermolecular momentum transfer. So these are the two forces which are responsible for creating the viscosity. Viscosity तयार करण्यासाठी हे दोन फोर्स रिस्पॉन्सिबल असतात. Viscosity म्हणजे काय? It is the resistance offered to the movement of one layer to the another layer, right? It is the resisting force. Viscosity is nothing but, okay, and it happens because of these two particular forces. What are that forces? One is the cohesive force, and second one is the molecular momentum transfer. Okay. In case of liquids, this cohesive force is predominant in nature. हा जो फोर्स आहे, हा फोर्स काय असतो? जास्त असतो as compared to this force. This is negligible in case of the liquids, but in case of the gases, this cohesive force is negligible, but this force is predominant in nature. Okay. So what will happen if we increase the temperature? Yes. Can anyone give the explanation for this? In case of liquids, what will happen? See, this is a pipeline. The liquid is flowing through this. Okay. And if we heat this water with a burner, okay, consider this pipe is a metallic, not a plastic pipe. And if we heat it, what is going to happen? Water will get heated, and the molecules which are present here inside this liquid, they will absorb the heat, okay, and they will lose their cohesion. Okay, this cohesive force, it will get reduced or it will get lowered. So because of that, if they lose the cohesive force is nothing but it is the force of attraction between two similar kind of molecules. Okay, so one layer is catching, or it is binding the other layer with this cohesive force. Now, if this cohesive force is reducing, it means that the binding force is reducing here, and it means there is a less viscosity. Okay, there is a less resistance to the movement of the layer. So the less resistance means there is a less viscosity. So with increase in temperature, the viscosity in case of the liquid is one decreasing, right? So I had given you the analogy at that time, analogy. So in the winter season, whatever the oil we use, coconut oil or hair oil, so it get solidified during the winter season. So at that time, it becomes solidified means cohesive force is increasing there. That means viscosity is increasing, right? Means with decrease in temperature, the viscosity is increasing there, right? So same case will be here. If you reduce the temperature, the cohesive force will be increased here. As the cohesive force will increase, the resistance to the movement of one layer by the another layer, it will increase. Means eventually the viscosity will increase. Okay. So this is the explanation for this relation between viscosity and temperature for the liquids. Now for the gases, this relation it will get just opposite to the previous one. Okay, so what is the explanation for this? Now in case of the gases, with increase in temperature, the viscosity also increases, right? So what is the justifiable answer for this? Now, just before few minutes, I have told you that the viscosity in case of gases, it is because of this molecular moment transfer. Okay, means suppose there is one pipe. In this pipe, these are the gaseous molecules which are separated apart. Okay, the basic difference between liquid and gases is that molecules are far away from each other in case of gases, right? Now here, the viscosity is nothing but it is the resistance offered by one layer or the one molecule to the another molecule. Now this all the molecules are moving in this direction because of the pressure. Okay, as they are moving in this direction simultaneously, they might be moving in this direction also, but resultant direction is this direction. Okay, now here, if we heat this pipe, if we increase the temperature of the molecules here, what will happen? This molecule will absorb the heat, and once they absorb the heat, their collision with the other molecules, it will increase. Their momentum, it will increase here. They will move in a random way. Okay, it means molecular momentum transfer, it will increase. One particle will collide with the other particle, and it will transfer the momentum from one particle to the another particles. Okay, and because of the increase in the heat here, the resistance, one molecule will collide with other molecules, and because of that, the resistance will increase, and that resistance is nothing but this one. This resistance is nothing but this is the viscosity. Okay, what is viscosity? It is the resistance offered by molecules to the movement of another molecules. If they are colliding on each other, then how they will move in this direction? Okay, so in case of gases, with increase in temperature, viscosity will increase. Okay, and if you decrease the temperature, if you reduce the temperature, then the energy absorbed by this molecule, it will decrease, means their moment will decrease, and eventually the transfer of momentum from one particle to the another particle, it will decrease, and thereby viscosity will decrease. So with decreasing temperature, the viscosity will also decrease. Okay, so this is the explanation for this, and this is the formula to find out the viscosity if you know these values. Okay, is there any doubt in this? Has everyone understood the concept, the relation between viscosity and temperature in case of liquids and gases? If anyone having any doubt, you can unmute and say it, or you can put your doubt in the chat box. No problem. Okay, I think no one is having any doubt. So let us write down this formula in your notebook. See, these are the mu0, then alpha, beta. These are the standard values. What is mu0? It is the viscosity of liquid at 0 degrees Celsius. So whenever any liquid reaches the 0 degree temperature, its viscosity will be fixed 1. It will not changes. Okay. So this value is fixed 1. And alpha and beta, these are the constants. These are also not changed. Okay. And T is the temperature. That is any temperature. With this formula, who is there? Rohit? So with this formula, we can find out the viscosity of any liquid at any temperature. Just now, I have told you, we have seen that variation of viscosity with temperature means if the temperature changes, viscosity is also changes, it will change. So at particular temperature, if you want to find out what is the viscosity of that particular liquid, at that time, you can use this formula to find out the viscosity of that particular liquid at that temperature, at any temperature, 20 degree, 30 degree, or 10 degree. Okay. So with the help of this formula, you can find out that mu is equal to mu0 into 1 upon 1 plus alpha t plus beta t square. T is nothing but it is that particular temperature at which we want to find out the viscosity. Everyone understood this? So let us now move ahead. So this is the question. It has been asked in IES examination 1993. What is the question? Decrease in temperature in general results in, these are the 4 options. Now you have to select the correct option. Tell me which is the correct one. The first option is an increase in viscosity of both gases and liquids. So that is not the correct answer. Option B, a decrease in the viscosity of both the liquids and gases. Again, this is not the correct answer. Option C, an increase in the viscosity of liquids and decrease in that of the gases. So option C, it looks correct one. Let us see the option D. A decrease in the viscosity of liquids. So that is the wrong answer again. Option C will be the correct answer. Yes. If you have got the correct answer, you can put your answers in the chat box. Tejasri has got the answer correct here, C option. Just now we have seen that relation of temperature with viscosity in case of liquids it is inverse. Means if temperature decreases, viscosity will increase. Okay. So here in options you can see there is an increase in the viscosity. Right. And in case of gases, the relation is directly proportional. With decrease in temperature, viscosity will also decrease. So you can see here decrease in temperature, decrease in the viscosity of the gases. So let us see the answer here. The option C is the correct one. The viscosity of water with increase in temperature decreases, and that for the air it increases. Next question. So this question was asked in ESE 2002. Now there is a one assertion and there is one reason. Okay. Assertion means there is one statement we can say, and for that statement the reason has been given. Okay. So we have to read this both, and then we have to select the correct option from this A, B, C, D. Okay. First of all, read the assertion and reason. What is assertion first? In general, viscosity in the liquids increases and gases it decreases with rise in temperature. Viscosity in the liquids increases with rise in temperature, whether it is correct or not. So you can somewhere write there whether the assertion is correct or not. Okay. A and R, you can write in short A and R. So if the A is correct one, you can write there tick mark. Okay. आपलं correct sign आहे आपण. You can tick mark there like this if the A is correct one. So you can write there A correct. If it is wrong, you can write like this. Then R. If it is correct, write like this. If it is wrong, you can write like this. Okay. So that while selecting the options, you will not get confused. Okay. हे ज्यावेळेस तुम्ही असं सिम्बॉल हे करचाल त्यावेळेस तुम्हाला ते इझिली. Okay. So here we were discussing about the assertion here. The assertion, can anyone tell me whether it is correct or right or wrong?
Wrong. Wrong.
Assertion is wrong one. Okay. So let us read the reason. What is the reason? Viscosity is caused by intermolecular force of cohesion and due to the transfer of molecular momentum between the fluid layers, but on of which in liquid the former and in gases the latter contribute the major part toward the viscosity. Okay. Former means previous one, latter means next one. What is the former? Of which the liquids the former and gases the latter. Former is the intermolecular force of cohesion, that is correct one, and for the gases transfer of molecular momentum, so that is also correct. So I think reason, now tell me from your side, I want answer from your side whether it is correct or it is wrong. Yes.
Correct.
Right.
So
Correct.
reason is correct one. So now let us see the options. Both option A and B, A and R are individually true. Okay. So this is a not correct option. Of both A and B, A and R are the individually true, but R is not correct explanation of A. Now here it is saying that A is also correct one, but A, we have found that A is wrong one. So the option B is also not correct one. Option C. Again in option C, it is saying that A is true answer, but it is not the case. So option C is also wrong one. Option D, A is false, but R is true. So it is matching with our conclusion. So the option D is the correct answer. So let us see that. So the option D is the correct answer for this. The explanation for that, it is given here, so that we have already discussed. So many students have got the correct answer, option D. So now let us see, after understanding the viscosity concept, so let us understand the types of the fluids. Okay. So we have studied this one also in our regular lectures. These are the different types of liquids: ideal fluid, real fluid, Newtonian, non-Newtonian, ideal plastic fluid. So what is the ideal fluid? Ideal fluid is the fluid which is incompressible and having no viscosity. It is known as the ideal fluid. Okay. So generally gases are compressible and liquids are incompressible. So for this liquids, we can say that liquids can be ideal, but in nature, not any fluid which is having zero viscosity. Okay, whatever the fluids are there in the nature, they are having some viscosity. At least some viscosity is there. So we cannot say that there is a ideal fluid. But in case of water, if you see, the viscosity is very low. So ideally, you can say that it is near to the ideal fluid, but it is not exactly, or it cannot be said that it is a true answer for that. Okay. So the ideal fluid is an imaginary concept. Okay, because in nature, though the liquids are incompressible, but they will possess some kind of viscosity. Okay. So this is ideal fluid is an imaginary concept. So real fluid is nothing but all types of fluids which are available in nature. They are having viscosity. They are called as the real fluid. Newtonian fluid is the fluid which obeys the Newton's law of viscosity, or they obey this mathematical expression: tau is directly proportional to du by dy, or the fluid in which shear stress is directly proportional to rate of shear strain or rate of shear deformation. So that fluid we call it as a Newtonian fluid. Then what is non-Newtonian fluid? The fluid which do not obeys this law is called as the non-Newtonian fluid. Okay. And last one is the ideal plastic fluid, the fluid in which shear stress is more than the yield value and shear stress is proportional to the rate of shear strain. So this is also follows the Newton's law of viscosity, but here this particular fluid, it possesses some shear stress before deformation. Okay, before deformation it will have some stress, its value is not zero. Okay, so such kinds of fluid, they are called as the ideal plastic fluid. So here let us see the examples of this Newtonian fluid, non-Newtonian fluid. Types of the fluids. Real fluid. All fluids that exist in nature are the real fluid. Newtonian fluid. Examples here: water, then ethyl alcohol, or it is also called as the ethanol, then benzene, blood plasma. These are the some examples of the Newtonian fluid. So you can note down these examples somewhere. Means in this particular fluid, the shear stress is directly proportional to shear strain. Okay, you will get the curve like this. Okay, but in case of non-Newtonian fluid, shear stress is not directly proportional to rate of shear strain. You will not get the straight line which is passing through the origin. Okay, what are the examples of non-Newtonian fluid? All types of pastes, gels, slurry, then ketchup, blood. These are the examples of non-Newtonian fluid. The question might have come in your mind that here also you have written blood plasma and here blood. Okay, so both things are different. Blood plasma is one constituent of the blood. Blood contains different types of constituents like WBC, RBC, then plasma. Okay, these are the constituents of the blood, right? Out of that, this is one constituent, blood plasma. It is Newtonian fluid, and blood is a non-Newtonian fluid. Okay. Is it clear to all? Any doubt here? If no doubt, then we will move ahead. Okay, this is the question. Put your answers in the chat box. Which one of the following sets of conditions clearly apply to an ideal fluid? This question has been asked in IAS examination 1994. Whether ideal fluid is viscous? No. The first option will be wrong. Then C for the second option. Yes, many students have put their answer B is the correct answer. So, let's check. Non. B option is non-viscous and incompressible. Correct one. Option C, non-viscous and compressible. So that is wrong one. Viscous and incompressible. Option D is also wrong one. So the correct option is option B. Okay, answer B is the correct answer. Here many students have got the correct answer. Next. Next question. There is one assertion and there is one reason. So here, जसं मगाशी तुम्हाला सांगितले त्याप्रमाणे या ठिकाणी note it down. Assertion, reason. Okay. What is assertion first? So this question it has been asked in IES examination 2007. Okay. What is assertion 1? A. Blood is a Newtonian fluid. So just we have seen blood is a non-Newtonian fluid. So the option A is wrong option, right? Second option, reason. The rate of strain varies non-linearly with shear stress for the blood. Whether option that R is correct, reason is correct or wrong. The rate of strain varies non-linearly, means not in straight line. It is moving like this. Means this is the condition for non-Newtonian fluid, right? So the blood is a non-Newtonian fluid. So this statement is right or wrong? Yes. I want answer from your side.
A is wrong and R is correct.
R is
Right.
True.
R is true. Okay. R is true. Now, after writing this one, so let us see the options. Option A, both A and R are individually true. So this is not the correct option. Both A and R individually true. Again, it is not the correct answer. Option C, A is true, but R is false. Again, this is not the true answer. Option D, A is false, but R is true. So according to our conclusion, option D is the correct answer. Okay. So let us see how many of you have given the answer option D. या अगोदरच्या प्रश्नाचं उत्तर आहे का आताच्या प्रश्नाचं आहे? Correct. Option D is the correct one. A is false, but R is true. Everyone understood this question? Is there any
Yes,
doubt
sir.
in this? I think no one is having any doubt. So let us move ahead. Our next property is surface tension. Okay. So now everyone knows what is surface tension. I have given you the example of surface tension, daily life examples. Can anyone tell me what is an example? Give an example of surface tension. Can anyone? Don't remember.
Water droplets.
Repeat it once again.
Water droplets.
Okay. The shape of the water droplet, spherical nature or shape of the water droplet, it is because of the surface tension. Correct? Again. Yes. At that time, we have seen one. I have shown you that images, two images or photos. That insect walking on the water, and another example, one pin. It was also, if we place it very smoothly, then it will also float on the water, right? Even though it is having uh, more specific gravity than water. Okay. So this reason behind that is surface tension. So what is surface tension and why it happens? What is the reason, main reason behind that happening surface tension? So let us understand it. So surface tension is nothing but it is a tensile force acting on the surface of the liquid in contact with the gas or on the surface between two immiscible liquids. Okay. हा surface tension phenomenon कधी ऍक्ट होतो ज्यावेळेस कुठलाही लिक्विड असेल if it is coming त्या लिक्विडचा जो सरफेस जो आहे if that surface is coming in contact with gas or if it is coming in contact with the surface of other liquid. Okay, for example, this is water and there is another layer here of the oil. Now there is a two different types of surfaces are there. Immiscible fluids are there. Immiscible means they are not mixing with each other. At that time, the surface tension force, a tensile force, it will act on this surface. Okay, and this tensile force acting on the surface is called as the surface tension. Okay, why this will happen? This will happen because of the cohesive force, the force of cohesion between the fluid particles. Cohesive force means the force of attraction between two similar molecules. In the diagram, you can see here the fluid particles. They are getting attracted in downward direction. There is a pull. Okay, so because of that, this surface, which is in contact with the gases or air, or in the contact with other liquid, this surface it will behave like a membrane under tension. Okay, this surface will behave like a membrane under tension. Okay, so this tensile force which is acting on the surface is called as the tensile surface tension. So what is the unit and what is the symbol? Sigma is the symbol that is used for denoting the surface tension. The SI unit of the surface tension is Newton per meter because it is acting on the circumference on the surface. Okay, so it is a Newton per meter. So surface tension is nothing but it is force per unit length. It is not per unit area, it is per unit length. So this thing you should keep in mind. So here you can see that surface tension is responsible for shape of the liquid droplets, right? The shape of the liquid droplet, it is nearly spherical. It is not exactly spherical because gravitational force, due to the gravitational force, it will not remain exactly spherical. In the absence of other forces, drops of virtually all liquids would approximately spherical, right? So this was about the theory part about this. We will see the equation for this also, and then we will see the questions. This is the question about the surface tension. It has been asked in IS examination 1998. What is the question? Surface tension is due to the, what is the option? Yes. Who will give the answer? Option B, correct. Correct. That is cohesion. So this was the question asked in examination. Surface tension is due to the cohesion between liquid particles at the surface where as capillarity is put later. Okay. Next, the dimensions of surface tensions are dimensions of surface tension are what is the answer for this? Yes. Can anyone know the answer? Option A.
Option Option A.
No, no, no. Just now
Option
I
B.
have what I can say.
Option D.
Option B.
Option B, watt per meter. Again, it is not the answer. See, आताच तुम्हाला सांगितलं तुम्ही तुम्हाला एक क्वेश्चन केलं तर दिस सिग्मा surface tension, it is not a force per unit area, it is force per unit length. So force is measured in Newton and length is measured in meter. So its unit is Newton per meter. And you are saying it's option A. It is not a stress. Okay. Option A is the wrong answer. Again, option B, someone has told. W is for the watt. So watt per meter, it is a Newton here. It is not watt. J is for the joule. What is joule? It is Newton meter. Am I correct?
Yes.
Energy is equal to force into distance, right? एखाद्या वस्तूला एका ठिकाणाहून दुसऱ्या ठिकाणी हलवण्यासाठी आपल्याला किती एनर्जी त्या ठिकाणी लागली त्या ठिकाणी आपण फोर्स अप्लाय करतो ओके अँड दिस पर्टिक्युलर ऑब्जेक्ट इट्स अ वेट आहे समथिंग लेट अस से एफ इज द फोर्स किती फोर्स लागला आपल्याला या ठिकाणी हे वस्तू इथं आणण्यासाठी दिस इज द डिस्टन्स सो एफ इंटू डी इज नथिंग बट एनर्जी एनर्जी इज मेजर्ड इन जूल ओके सो जूल इज इक्वल टू न्यूटन मीटर okay so here instead of Newton what we can write if I take this meter here on this side so Newton will be equal to joule per meter so here instead of this Newton I can write joule per meter and there is one already meter there so here we can write joule per meter square. So option C is the correct option here. Have you understood everyone?
Yes, sir.
Yes, sir.
So option C is the correct option here. Joule per meter square. How it has come? Joule is nothing but it is Newton meter. So Newton will be equal to joule per meter. Now we know the unit of that surface tension. That is, it is Newton per meter. Instead of this now Newton, I will put Newton joule per meter, and already there is one meter in denominator, so the unit will be joule per meter square. So the option C is the correct answer. So let us see it. So this is the explanation for this. Not necessary to read all these things. From here you can read in SI unit the surface tension is expressed in Newton per meter or joule per meter square. हे फक्त हे युनिट जरी आपल्या आपण ध्यानात ठेवलं तर याच्यापासून आपल्याला हे युनिट तयार करता येतं आपण जसं आता केलं तसं right? Okay. Next question. So this question, it has been asked in GATE exam 1996. The dimension of surface tension is. Who will tell the answer? Put your answers in the chat box. Option A, option B, option B. Yes, anyone? Option A. What is the dimension of Newton? See, surface tension we measure in Newton per meter. And meterचे dimension आपल्या या ठिकाणी आहे MLT. So this is the L, is the dimension for this M. What about the Newton? It is a force. Force is equal to mass into acceleration due to gravity. So M is for mass, acceleration is for, it is velocity, change in velocity with respect to time, right? Or it is M into velocity is measured in distance per unit time, so it will become T square here. So the dimension for the force or the Newton will be M L T raised to minus 2 divided by this M, that is not M, L. M is the meter, it is the unit of meter distance. So distance is measured in dimensionless, it is represented by letter L, right? So this L, it will get cancelled and you will get the dimension as meter T raised to M into T raised to minus 2. Okay, so option D is the correct answer. So here, let me check how many of you have given the correct answer. Shubham Bhagwat has given option D. Then Honmute, Prajakta, Sonali Shinde, and Tejasri Pite. So these students have got the correct answer, option D. So let us check it. Option D is the correct answer for this. That is meter per T raised to T square meter. Everyone understood how to find out these dimensions? Or should I repeat it once again?
Repeat, sir.
Okay, I will repeat it once again. See, surface tension is nothing but it is force per unit length, right? Now, in dimensions, there are basic 3 dimensions that we use. MLT, M means mass, L means length or distance, and T means time. Now here in the numerator, there is already one L is there. Now about the force. Force is measured in Newton, or force dimension जर आपल्याला काढायचं असेल तर काय करावं लागेल, F is equal to हा फॉर्म्युला लिहावा लागेल, mass into acceleration, okay, M into A, according to Newton's second law of motion, second or first law. F is equal to M into A, right? So this mass, it can be written as it is here, M. Okay. Now what about acceleration? Acceleration is nothing but it is change in velocity with respect to time, right? What is velocity? Velocity is nothing but it is change in distance or length per unit time. So here, instead of V, I can write L divided by T. So there is already T here. So it will become T square. So the dimension of acceleration will be L by T square, right? So put this dimension here, right? Yeah, you can talk on that. So you will get here L into divided by L divided by T square. T square, correct? So this L will get cancelled, and you will get the dimension M divided by T square, or we can write M into T to the power minus 2. Okay. Has everyone understood this one? How to find out these dimensions? Still, anyone having doubt? Okay, those students who are having doubt, okay, or those students who have joined late, or because of any reason, if you are not able to attend, you have missed some part of this lecture, I am going to put this video on the YouTube channel. Okay, so you can watch there. So I will share you the that link of that videos. Okay, so you can later on also watch that particular videos if you are having any problem. Okay, no doubt. So let us move ahead. Now, these are the derivations to finding the surface tension acting on a liquid droplet. Then there is another derivation we have seen for the liquid Z, and third derivation we saw that at that time about the hollow spherical bubble. Okay, right. So here we are not going to derive all these things here. Is this Viresh Kumar Kamble, 36A. I have not asked you to give the presentee attendance here. I will take it. Okay, don't worry. So we have 6 minutes yet. Or should I take your attendance first? Okay, within last few minutes, I will take the, your attendance. Okay, no problem. So just here, you go on writing this formulae. Okay. The first expression, first derivation is for finding the pressure intensity inside the liquid bubble. हा जो not bubble, liquid droplet. हा जो liquid droplet आहे, या liquid droplet मध्ये जो प्रेशर या ठिकाणी आहे, प्रेशर इंटेन्सिटी, इट इज इन एक्सेस, जास्त आहे कशापेक्षा, बाहेर जे ॲटमॉस्फेरिक प्रेशर आहे त्या ॲटमॉस्फेरिक प्रेशर पेक्षा आतमधला प्रेशर हा जास्त आहे. ओके, कशामुळे जास्त आहे? इट इज बिकॉज ऑफ द सरफेस टेन्साइल फोर्स ऍक्टिंग ऑन दिस लिक्विड ड्रॉपलेट. हा लिक्विड ड्रॉपलेट वरती जो ऍक्ट होणारा सरफेस टेन्शन फोर्स आहे तो काय करतो, आतमध्ये या ठिकाणी पूर्ण हा जो बबल आहे, हा जो ड्रॉपलेट आहे, हा ड्रॉपलेटला स्क्वीज करण्याचा प्रयत्न करतो आणि त्याच्या अगेन्स्ट मध्ये हा प्रेशर इंटेन्सिटी आतमधून या ठिकाणी ऍक्ट होत असते त्याच्या अपोजिट डायरेक्शन मध्ये. ठीक आहे. सो दिस एक्सेस प्रेशर इंटेन्सिटी इज गिवन बाय दिस इक्वेशन P is equal to 4 sigma divided by D. Okay, so note down this formula to find out the excess pressure intensity inside the liquid droplet. P is equal to 4 sigma divided by D, where sigma is nothing but it is surface tension and D is the diameter of that liquid droplet. Okay, now from this expression you can see that this pressure intensity is inversely proportional to this diameter. Means if the diameter increases, if the diameter decreases, this P will increase, and if the diameter increases, the P will decrease. And it is directly proportional to the surface tension. Means If the surface tension is more, the pressure intensity inside the droplet will be more. Okay. I have written this formula. Now, let us move ahead. So there is a question on this, which is asked in IES examination 2008. What is the pressure difference between inside and outside of the droplet of water? What is the option? Put your option in the chat box, answer in the chat box. Till that, I will take your attendance.
Get qualified Ritujaa Nagesh 20